Claude AI has released its latest Opus and Sonnet models, which claim to outperform competitors like Gemini, ChatGPT, Deepseek and Grok on several benchmarks. My name is Mehrdad Arashpour, and today we'll review Claude Code's capabilities. We have designed 3 coding challenges, and the first one is to create a visual app for Project Risk Register. It must automatically calculate risk priority levels and color code them based on a 5x5 matrix. The second coding challenge is to build a visual app that simulates collision of 2 spiral galaxies. The simulation must show star formation rates spiking during the collision. The third coding challenge is simulating a car manufacturing line. It has 3 robotic arms that weld, paint, and assemble parts on the car chassis. Stay with us, and together we'll evaluate the performance of Claude 4. Let's head over to Claude.ai and experiment with the available models. The primary models at the time of recording this video are Opus 4, Sonnet 4, and some other versions. Opus needs a Pro plan, but Sonnet 4 is free to use. Let's test Sonnet for our first coding challenge with this prompt. Build an interactive project risk register dashboard with risk impacts and likelihoods shown before and after mitigation. Priority scores, which are the product of impact and likelihood, are calculated and color-coded for several risks. The color coding is based on a 5x5 matrix, which is also visualized. As you can see, around 390 lines of codes are generated by Claude, with latency of less than a minute. The code starts with importing the React, which is the main library. This is a reasonably clean code and well commented. I didn't like the visualization in the first version and asked for a couple of modifications. After 2 rounds of bug fixing, the code is finally executable, and you can render the dashboard in the preview window on your web browser. The dashboard has a proper title followed by a color-coded 5x5 risk matrix. As you can see, likelihoods are shown on the horizontal axis and impacts are visualized on the vertical axis. Risk priority levels are products of likelihood and impact. For low scores of 1 to 5, a green color is used on the matrix. Medium risk levels are visualized by shades of orange and yellow. Finally, critical risk levels, which are above 20, are shown by red color. The numbers inside the risk matrix show how many risks are in each category. There is a toggle to change both risk matrix and risk register based on scenarios we have before and after mitigation. For example, let's click on the first risk of budget overruns. The pre-mitigation impact with a score of 5 has been reduced to 4 after mitigation. Also, the pre-mitigation likelihood of 4 is reduced to 2 post-mitigation. The dashboard also lists mitigation strategies, which are weekly budget reviews, contingency planning, and vendor negotiations for this particular risk. We have the same story for other risks. As you can see, Claude has done a reasonably good job in the first coding challenge, for which we scored 90 out of 100. This is mainly because of the 2 rounds of bug fixing and the fact that Claude couldn't perform the task in my prompt and place the legend next to the risk register. We are now ready to move to the second coding challenge. By the way, only around 45% of channel's regular viewers are subscribed. If you are enjoying our content, please give it a thumbs up and consider subscribing. Thank you. In this stage, we want to build a visual app that simulates collision of 2 spiral galaxies. The simulation must show star formation rates spiking during the collision, and new stars are being born from the chaos. The spiral arms are being torn apart and reformed again. It's destruction and creation happening simultaneously. We need toggles and controls to be small and do not block the visualization. With a latency of around 1 minute, Claude generates 470 lines of code this time. Let's view the visualization. 2 spiral galaxies in blue and orange color are colliding, and purple dots represent the formation of new stars. I decided to challenge Claude 4 by asking a more complex logic. This is my prompt. Please add visual flags when stars are distracted or galaxy cores interact. Core merger logic is purely distance-based without modeling actual merging or disruption. Some mathematics, including spiral arm calculations or distortion effects, do not have annotations. Surprisingly, after running this prompt, the model generated 15 different versions of the code, which took more than 5 minutes. Version 15 has 635 lines of code and unfortunately is not executable with several errors. This is really disappointing, and for this second coding challenge, which can be considered a graduate level reasoning task, we have to assign a mediocre score of 60 out of 100. We are now ready to move to the third coding challenge. Let's start with this prompt. Create a HTML code for the exact replica of a car manufacturing line. Make sure the welding and painting robots are working and don't forget the car chassis in 3D. This time the generated code is 1067 lines, which took the model almost 180 seconds to generate. As you can see, the visualization of robotic arms is very primitive with detached end effectors. This time we challenge the model and gauge its domain-specific expertise in the field of mechatronics. So here is my new prompt. Refine robotic arms to have 3 joints and a detailed end effector, such as paint sprayer or welding bits. The final assembly arm should put the car body on the chassis. This prompt triggered the model to generate 7 versions of the code with some bug fixing required. The visualization in version 7 looks like this. As you can see, there are some improvements in the visualization, but robotic arms are not doing any task on the chassis. One of the joints shows some movement, but the arm is static with no degrees of freedom. Because of these issues, the overall score for this challenge is 70 out of 100. So let's have a recap and calculate the average score for the creative problem-solving tasks that we assigned to Claude 4. A respectable score of 90 for the first risk analysis dashboard, a mediocre score of 60 for visualization of colliding galaxies, and a score of 70 for the car production line. Our average score is 73.3 for the 3 tasks that can be considered as graduate-level reasoning. This is slightly below the score of 75.4% for Sonnet 4 on the Anthropic website. Remember, LLMs might perform very well in pattern recognition, but struggle with novel reasoning tasks. This is usually the case that overfitting to benchmarks inflates performance of LLMs. Hopefully, you found our review of Claude 4 in this video helpful. If yes, please give it a thumbs up and consider subscribing to our channel. We'll see you in the next one.